Hi kids, welcome to Limit Review. So this handout is on our Canvas site, and there's obviously problems on the front and the back, and I've only picked a number of them, as you can see circled, to do with you on this video to remind you, and hopefully I'm hitting all kinds of different issues when you have to analyze them graphically, maybe by a table, functions you should know. All of these would be on the non-calculator portion of the AP exam. So as I start off here with number 4, remember that your first step is to plug in. But when I plugged in a 2 into number 3, I'm going to factor this denominator. I got right when I plug 2 in, 2 minus 2 is 0, 0, so I got 6 over 0, which is obviously undefined. But remember, the function is undefined at 0, so I need to know what the graph is doing without a calculator at 2. Since the bad x did not cancel out, I have a vertical asymptote. I just need to know which swoosh what kind of swoosh I have, right? So I need to think about, well, what's happening as I plug in a number like 1.9 and 1.999. If I plug in 1.9 into here, my numerator is approximately close to positive 6. If I put 1.9 in here, the first factor of the denominator is positive, but 1.9 minus 2 would make a negative. So I would have a positive times a negative, which would be a negative something really close to 0. What is positive 6 over negative 0.000, something really, really close to 0? Swoosh down. How about a number greater than, to the right of 2? Plug in a number like 2.1. That's still approximately positive 6-ish. Plug in 2.1 here to the first factor of the denominator is positive. 2.1 minus 2 is also a positive number. Positive times a positive is a positive number, really close to 0. But positive 6 divided by positive number really, really close to 0 is going to swoosh up. So this overall limit does not exist, right? Because my range walkers, whoosh, going down on the right, the left, and going up on the right. They do not meet. Look at this one. This one is asking the limit as x approaches 0, but only from the right. We've done this one a couple of times now, right? If I don't know what this graph looks like, I'm making a table. So this limit, I had to use algebra, factoring, and graphing, along with numerical analysis. Here, I'm just going to make a table. When x is 0, the absolute value over 0 is undefined. Absolute value of 0 over 0 is undefined. But when I put in a number like a half, I get positive 1. Like a fourth, 1/4, the absolute value of 1/4 over 4 is 1, right? So the graph, as x approaches 0 from the right, this limit is 1. All right, here is a product of two functions. So the limit of a product is the product of the separate limits. So as you approach 0 from the right and left of e to the x is continuous, so the limit is equal to the function value, and e to the 0 is 1. So that limit is 1. And the limit of cosine of 0 is also 1. So the limit of e to the x as x approaches 0 is 1. The limit of cosine x as x approaches 0 is 1. The limit of the product is the product of the separate limits, and 1 times 1 is 1. Here's the pattern I told you that AP loves, so you should just memorize it as long as you are in radians and going to 0 and you have a ratio of a sine thing over a polynomial thing, and next to the first, the limit is the ratio of those coefficients as long as you're going to 0. Hey, this looks like, is this the pattern? I'm not going to 0. I'm going to pi. What's your first shot with a limit? Plug in. Cosine is continuous. X, the function cosine is continuous, so you can just plug in. The function x is continuous, just a line, right? You can plug in. Then the ratio will be continuous as long as neither one of these values is 0. I'm sorry, the denominator is not 0. Cosine of pi is -1, and pi is just pi. So that's -1 over 3.14-ish. So this one, I think this is from the left. It's hard for me to see that. What is cosecant doing from the left? I don't know. At pi. I don't know. But cosecant is actually the reciprocal of sine. And since sine is 0 at pi, cosecant is undefined at pi. And from the left, cosecant approaches that vertical asymptote that way, the reciprocal of the blue parabola looking thing. Right? But this is the only behavior that they're asking me about. Again, if I'm not reading that right and it says pi from the right, well, then the answer would be -infinity. I didn't do this one, but remember this is your step function. So just use your table to do that. And plug in numbers like 2.99 and 3.111. All right, on the back, here are some limits, some more limit problems. I'm going to leave number 2 for a little bit because I want to highlight that these 3 problems, 4 problems, 5 problems, are all N behavior problems. N behavior. So, since I'm plugging in a number that is very, very large, right, as x approaches positive infinity, since x is, as you're putting in huge numbers in and squaring, that allows you to say, you know what, this +2, you bother me. You bother me, right? I don't even, you're like a little fly on my shoulder. I don't even pay attention to you. Because remember, I'm plugging in 1 billion and squaring it. Adding 2, So what is the square root of x squared minus x? Well, you're putting in positive numbers, so the square root of x squared is just going to be x. X minus x is 0. Can you see what I would do over here? I'd kind of do the same thing, right? I'm going off to infinity. Guess what? If I'm going to positive infinity, this +1 is meaningless, and this +2 is meaningless. So what do I have? The square root of x squared over x, but the square root of x squared, because you're putting positive things in there, is just x. X divided by x is 1. Right? And the only time I have to worry is if x is 0, but I'm putting in huge numbers for x. Crazy. Here again, we have another limit of a product, which means that the answer is just the product of the separate limits. What is the N behavior of e to the negative x? right? There's e to the negative x, which is the same as 1 over e to the x, right? Which is 1 over 2.7-ish to the x. That base is smaller than 1, so that's why your exponential function, the end behavior, is 0. 0 times I don't care is 0, right? Right, the end behavior of sine, well, it kind of oscillates, but it oscillates between 1 and negative 1, right? So numbers between 1 and negative 1 times 0 is 0. Check out this one. This is going to negative infinity. So remember, since I'm going to negative infinity, once again, this plus 3 doesn't matter, and that 5 doesn't matter. So remember, I'm plugging in negative values of x, right? Plugging in negative values, right? So I get a negative up here. And then you're doing the square root of 6 times the square root of x squared, right? So what do I get out of that? I get a negative x, because you're putting in big numbers here but negating them. And then you have root x, and the square root of x squared is x. Those cancel out. The limit is negative 1 over root 6. Crazy, whack, funky. Here's another one. Going off to negative infinity, arctangent, remember, is the same as inverse tangent. If you don't remember how to graph inverse tangent without a calculator, you better know how to graph tangent. There's tangent. Tangent is undefined at pi over 2 and negative pi over 2. Inverse tangent is switch x and y. So your vertical asymptotes become horizontal asymptotes. This is tangent, and this is inverse tangent. Sorry about that. Crazy. Now look, what is the limit as x goes to negative infinity? What is the limit? All because I knew tangent was undefined at negative pi over 2. So inverse tangent has a horizontal asymptote at negative pi over 2, and the graph swooshes off towards that, or slides off towards that. Now I'm going to erase these while I do number 12 to give myself, oh, actually I can, you know what I can just do? I can just go over here. I'll do number 12. I got to do some fraction work before I can figure out what's going on here. Because notice I try to plug in 0 and I can't plug in 0 to the denominator. So I'm going to have to do some algebra. Remember, division is the same as multiplication by the reciprocal, right? Division by x is the same as multiplication of 1 over x. Now I'm going to get a common denominator here, right? What's my common denominator? Well, imagine that you had, right, 1 over 5 minus 1/4. What's the common denominator, right? The common denominator would be 5 times 4. So my common denominator is 4 plus x times 4, right? That's my common denominator. Now, I have to multiply the numerator to get, right? I have to multiply my numerator by what's 4 plus x, I need to multiply this numerator by 4. Well, 1 times 4 is 4, and just like over here, you would multiply this one by 5. I am multiplying this numerator by 4 plus x. And remember, I'm still multiplying by 1 over x. So minus 4 minus x, but I have a positive 4, just gives me a negative x. Oh, snap. Those x's went away. And I have negative 1 over 4 plus x times 4. What are you supposed to do after you do algebra and cancel out something? Re-plug in. Plug in 0 for x. And I get negative 1 over 4 plus 0, which is 4, times 4, which is 16. Math is cool. All right, let me go up here and do number 2. There's a trick with number 2 that might not be obvious to you, but once I've shown it to you, now it needs to be in your bag of tricks. I can't plug in 25, right? 25 minus 25 is 0. But watch me factor. Watch me use the difference of two perfect squares in a weird way with x minus 25. Gasp. What up now? What up? Right? Take a moment and see if I'm right. Square root of x times the square root of x is x. The middle two terms will drop out, and negative 5 times positive 5, right? We don't give this to you in algebra as the difference of two perfect squares because we say that an x to the first is prime because square root of x is not rational, right? So we call polynomials prime if you can't break it down into rational factors. This is not rational factors. It's just like saying 13 is 6.5 times 2, right? It's true. We still call 13 prime because 6.5 is not an integer. Now look what happens. I can cancel, and after I cancel, what am I supposed to do? Re-plug in. Woot woot. All right. So that's in class. We will have time to look at some of these other ones or for you to ask me questions about any of these. Be careful with number 4. If you need to look up the how to expand a cubic, either using Pascal, the binomial expansion, Pascal's triangle stuff, or the just pattern recognition we taught you in Algebra 2 or in AF, don't stress about it if you don't remember that. It's not something that comes up often on the AP test. All these ones that I circled, pretty important, okay? They tend to come up. All right, and I will see you later.